So in our last class, we had a review, and so we did review of a section 2.8, section 3.1, and one more time from section 2.8. There is like two type of a problem that you need to practice. Okay, one type is that you have to graph the given function using the transformation. You will be given a function and you will be asked to graph that function using the different transformation and write like those transformation. You also need to write what kind of transformation did you use to graph. Okay, so this is one type. And the next type is that, so next type of problem is that you will be given a description of the transformation, and from that description of a transformation you have to write the function. So this is the different two type problem that you need to practice from section 2.8. From section 3.1 quadratic function, the very first problem you need to practice is that writing a given quadratic function in a standard form and finding the vertex. Okay, so this is the one that we did. So you are given the function in a general form. Okay, you have to write this function in the standard form. So you should know how to rewrite the given function in a standard form. Okay, and find the vertex. The next is that you will be given a function. You will be asked to find the vertex, axis of symmetry, maximum, minimum, graph the quadratic function, and you might be asked to write the interval where the function is increasing or decreasing. And that's what we did in our last class. So we had a graph here. Now for this graph, if we want to write down the interval where the function is increasing, can you tell me the interval where the function is increasing? We can extend this graph all the way to the left and all the way to the right. So what is the interval where the function is increasing or decreasing? Okay, yeah, so we are always moving from left to right. Okay, so let's say we are at infinity. So we are at infinity, negative infinity on the left, and as you are moving from negative infinity to this point, so this is the x coordinate of vertex. So our function is going up, right? It means the function is increasing. So the interval where the function is increasing is negative infinity to negative 3/2. Okay, so this is the interval where the function is increasing. Similarly, from negative 3/2 to all the way to the positive infinity, our function is going down, right? So this is the interval where the function is decreasing. So from negative 3/2 to positive infinity, this is the interval where the function is decreasing. And to find this interval, you need to know the vertex. Okay, you should know the vertex, and the vertex give us this x coordinate. So finding the vertex is the key. Whenever you have the quadratic function, you should know how to find the vertex. Okay, now the next type of problem from this section is that there will be a real life application. Okay, and in that real life application, the question is that you will be asked to find the maximum value or minimum value. And finding the maximum value or minimum value is same as finding the vertex. So you will be given a quadratic function, okay, similar to this function. So you will be given a quadratic function and you will be asked to write down what is the maximum value and where do you find that maximum value. And that is same as finding the vertex. So you find the vertex of the function and that gives us the maximum value. Okay, so let me find an example here similar to that. Okay, so this is review section 3.1 number 19. So this is page number 312. Okay, so this is page 312. and number 19. So here we have our rectangular play area is to be enclosed with a fence on a 3 of its side and a brick wall on the 4th side. So we have our rectangular play area. So let's draw a rectangular play area. Okay. So we have this rectangular play area, and we need to fence this rectangular area with a fence on the 3 side, and in one side we're going to have a brick wall. Okay, so let's say we have a brick wall on this side. So we already have a brick wall, so we don't need to fence this side, right? So we're gonna use 120 feet long fencing material to fence 3 sides of this playground. Okay, so let me call this side is length, this side is width, and this will be also W, right? Now what is that 120 equals to here? So we have a 120, so 120 feet long fencing material, and we use that material to fence 3 sides of this rectangle. So how can we rewrite that 120? So we're gonna use 120 feet. Okay, so we have 120 feet fencing material. Okay, and we use that 120 feet fencing material to fence 3 sides of this rectangle. So 1 side, 2 side. So we use this 120 feet fencing material to fence these 3 sides. Now what is 120 feet? Can I write 120 equals to this W plus L plus W? Can we rewrite this in this way? So we have 120 feet fencing material, and we use that 120 feet fencing material to cover the 3 sides. Okay, and the 3 sides is, we don't know what are their dimension 8. Okay, so we use L as a length of the length here, and W as a width of this rectangle. So we don't know what are these dimension, and sum of these 3 sides has to be 120 feet. Okay, so this is, we have 120 equals to, these two are like terms, so we have 2W plus L. Now the question asked to us is that what dimension will yield the maximum area? Now we need to find the dimension, we need to find length, we need to find width, such that we get the maximum area. Okay, now before that we need to define what is area. Now what is area for this rectangle here? So how do we find the area? Area is length times width. Okay, and in order to find the maximum area, we need to have our area in terms of one variable. So we have a 2 different, length and width. So we're gonna rewrite area in terms of length or width. It does not matter. Okay, now you're gonna use this equation. Okay, let me call this equation, and solve for one of the variable, W or L, it does not matter, and substitute in the area. Okay, now so from this equation 1, can I is our L is equals to 120 minus 2W? Do you agree? So if you subtract 2W on both sides, so our L, so this cancel, our L is 120 minus 2W. So let's go ahead and substitute this length. So this is, our length is 120 minus 2W times W. In order to find the maximum, we need to have the quadratic expression. Now let's distribute this. So you distribute W to 120 and negative 2W. So this is W times 120 W negative 2W square. Okay, and I can rewrite this as a negative 2W square plus 120W. So this is area in terms of W. Okay, now we have this area function in terms of W. But you can make a substitution for W. Okay, you can have an area in terms of length. So now this is the quadratic function, and we are asked to find the dimension such that we get the maximum area. So finding the maximum or finding the minimum is same as finding the vortex. So this is the quadratic function. So let's go ahead and find the vortex here. In order to find the vortex, we need to compare with our function f of x equals to ax square plus bx plus c. If we make a comparison for f, our function is area, our input is w, okay, a is -2, x is w, right, b is 120 and c is 0. Now what is the formula to find the vortex? It is h, right? Now in this specific case, what is our h? What is the input for the area function? Our h is the input or the x coordinate. Now for our this area function, what is our h? Is it L or W? Yes, it's a W. Okay, like whatever we have. See, if you compare here, so instead of x we have W, right? Our x is the h, so h is same as W, and this is negative b over 2a. This is the formula that you need to know. So we have negative as it is. Our b is 120 divided by 2 times our a is -2. So we have negative 120 divided by -4, and that is 30. So 30 feet is our width. Okay, now let's find the y coordinate. So finding y coordinate of a vortex is same as finding k. Okay, and what does k represent in our case? K is y coordinate, and our y coordinate is area. Okay, and this area is, you substitute 30 for every w in this function. So we have -2 times 30 square plus 120 times 30. So finding maximum or a minimum, it is same as finding the vortex. Okay, you find the x coordinate, you find the y coordinate. In our area function, our input is w, so for h we have w. Okay, and our output is area, so for our y coordinate we have a. Okay, now if we simplify this, we have -2 times 30 square is 900. 900 times -2 is -1800, plus 120 times 30 is 3600. Okay, and this is positive 1800. So our maximum area is, so we know the maximum area is 1800 feet square, and maximum width is 30. Now what will be the length? That's what we need to know. Now what will be the length? We know the area, we know the width. Now how do we find length? So you are given the area 1800 feet square, okay, and width is 30 feet. Now what is the length here? So how do we find length? We use the same, area equals to L times W. Okay, area is 1800 equals L. That's what we need to know. W is 30. So we divide both sides by 30. So this cancel. Okay, 1800 divided by 30, is it 60 feet? Okay, is our length. So 60 feet is the length and width is 30 feet. That's what we want as our answer. And this is the dimension. It has to be the dimension in order to get the maximum area. Okay. So here the general concept is that if you are asked to find the maximum or a minimum, if you see a maximum or a minimum, then you are finding the vortex. Okay, you find the vortex and you have the answer. Okay, the y coordinate give us the maximum. So here our function is area function. A is the area function and the maximum area is the y coordinate. Okay, and we find this maximum area when our width is 30 feet. So if you are asked maximum minimum, find the vortex. but make sure you will be given a quadratic function, or like sometime you might need to find the quadratic function like we did here, or sometime you will be given a quadratic function and you just need to find the vertex and interpret that. Okay, any question? So these are the type of question that you need to practice from this section. One is finding the maximum minimum of a real life problem. Okay, second is you will be given a function, finding the vertex, axis of symmetry, drawing a graph, finding the x-intercept, y-intercept, increasing, decreasing interval. And the third question is rewriting the general quadratic function in a standard function and finding the vertex. So this is the third type of question that you need to practice for this exam. Okay, now let's go to our last section, section 3.6. So in section 3.6, we talk about the rational function. Okay, and let me start with the, okay, so for this rational function, we do have a review problem from the exercise as well. So let me take an example here. The very first type of a question is that you will be given a graph of a rational function. So let me do number 22. Okay, and you are given the graph of a rational function. So let me draw the graph here. So this is 1 0, this is negative 1 0. You have a vertical line at positive 1, or you can have a solid line, and the graph is so this is the graph. Okay, so here, so this point is 0 1. Okay, this is 0 1, this is x-axis, this is y-axis. So you will be given a graph for some rational function. Okay, now here is the question for you, finding the domain of this rational function. Now, so we have the domain, we need to find the domain. Now at first, in this graph, what are these vertical line? What do we call this vertical line? Vertical asymptote. Okay, what do we call this point? Okay, if we take that part of a graph, then it's a vertex, right? But this is one function. That's the y-intercept. Okay, now if we know that these two are the vertical asymptote. Now what will be a domain for this function? It means what are the x values that this graph can have. So we have this x-axis, okay, and x-axis has every number from negative infinity to positive infinity. Okay, that's a number line. Okay, now from negative infinity to positive infinity, what are the x values that this graph can have? That is the domain. So what will be the domain for this function? Can this graph have had every real number as a domain? Okay.
Is negative infinity to negative 1 union negative 1 to 1 union 1 to 3?
Okay, now here this is a rational function, and if you have a rational function, then the vertical asymptote, if you have a vertical asymptote, the point where you have the vertical asymptote, these are not the domain, but every other number are the domain. Okay, now this function has a vertical asymptote at negative 1, okay, and positive 1, and these two numbers are not the domain, but every other real number are the domain. Okay, so at vertical asymptote, your function is undefined, and that is the reason why we have the vertical asymptote. Okay, if our negative 1 and positive 1 is the domain, we won't have vertical asymptote. We define the vertical asymptote for the x value where our output is undefined. Okay, so every number other than -1 and +1 is the domain. So let's write that in an interval notation. So if you need help here, you can just draw a number line. So we know -1 is not a domain, so we have an open circle, and we know +1 is not a domain, so we have an open circle. Now we rewrite this part of a number line in an interval notation. So you exclude the point where you have the vertical asymptote. Okay, every point where you have the vertical asymptote are not the domain. So what is the interval notation for the first part? That is from -infinity to -1. Since we have an open circle, we are excluding. So we're going to have a parenthesis union for the middle part from -1 to +1. Both of these are not the domain, so we're going to exclude. It means parenthesis union 1 to infinity. So this is the domain. You will be given a graph. You will be given a vertical asymptote. So you find the point where vertical asymptote is, and you exclude those points from the real number. That is the domain. Okay, so that's the first type of question. The next is you will be asked to write down the x-intercept and y-intercept. Now for this function, do you have x-intercept or not? X-intercept means you are looking at the point where graph crosses x-axis. Now for this graph, if you extend your graph all the way to the left or all the way to the right, it never crosses the x-axis. It means no x-intercept. Okay, so we don't have x-intercept. Now what about y-intercept? Do we have y-intercept? Okay, and that y-intercept is 0, 1. Okay, 0, 1 is the y-intercept. Y-intercept is the point where graph crosses y-axis. Okay, now the next is that you will be asked to write down the asymptote, vertical asymptote and horizontal asymptote. Now, do we have any vertical asymptote and horizontal asymptote? And yes, so whenever you are writing the vertical asymptote, make sure you have x equals to, and if you are writing the horizontal asymptote, y equals to. Okay, vertical asymptote is x is equals to, so these two lines are the vertical asymptote. So this line is at -1, so x equals to -1 is one vertical asymptote, and we have this second vertical asymptote at +1, so x equals to +1. These are two vertical asymptote. If you don't write this x, then you won't get the credit. Okay, because vertical asymptote is a vertical line, and for every vertical line the equation is x equals to some number, x equals to x-intercept. Okay, now the last is, do we have a horizontal asymptote for this graph, for this function? Okay, do you all see that y equals to 0 as the horizontal asymptote? Okay, now here, as we extend, as we choose our input to be greater or to be smaller, the output is very close to this line, which is y equals to 0 line. The output is very equals to 0. So if that is the case, y equals to that number, which is 0, is the horizontal asymptote. Okay, so finding horizontal asymptote means when you choose your input to be very large or when you choose your input to be very small, if the output, if the graph is very close to some number, like here, so when we extend on the right side, this function is very close to this line, and this line has a y coordinate 0. It means output is very close to 0, and if that is the case, y equals to 0 is the horizontal asymptote, and horizontal asymptote is a horizontal line, so you must have y equals to a number where the function is close. Okay, so this is the one type of a question. You will be given a graph, you will be asked to write down the domain, you will be asked to write down horizontal asymptote, vertical asymptote if it exists, you will be asked to write down the x-intercept, y-intercept, Okay, so this is one type. Now should be the last. Now the last type of question that you're gonna have from this section is, okay, you will be given a function. Now you won't have a graph, so let me take a function. Okay, let me take number 5 from page. Okay, let me make sure, did I mention the page for this one? Okay, so this is page number 298. Okay, so this is 22 number. Let me do number 5 here. So we have a function, rational function, -2/x plus 6. So this is the function. The question is pretty similar to the one that we just did. The only difference is that in the previous we were given a graph, now we are given a function. The first question is finding the domain for this function. Okay, let's find the domain for this function. This is a rational function. So if we have a rational function, what kind of number we can't have as a domain here? We can't have 0 in the denominator, and here when our input is -6, we get 0 in the denominator. So -6 is not the domain, but every other real number is the domain. Okay, so you find the number that make denominator equals to 0, and that number is not the domain. Okay, so the domain is every number other than -6. So let's draw a number line, -infinity to +infinity. -6 is not a domain, so we're going to have an open circle. But every other number on the left of -6 and on the right of -6 is the domain. So let's write in an interval notation. The first part is from -infinity to -6. We are excluding -6, so we're going to have parentheses. And this part is from -6 to +infinity. And you have a union here, and this is the domain. So if you are asked to write the domain, make sure you write in the interval notation. Okay. And for the rational function, every number that make denominator equals to 0 is not a domain, but every other number is a domain. This is the one question that you gonna have. The next is that finding the vertical asymptote and horizontal asymptote. So find vertical asymptote and horizontal asymptote for this function. Now we didn't have a graph here. So what will be the vertical asymptote? How do we find the vertical asymptote when we are given a rational function? So in order to find the vertical asymptote, at first we find a number that make denominator equals to 0. So you find every number. Okay, sometimes you might have a 2 number, or you might even have a 3 number. Okay, so you find every number that make denominator equals to 0. Now in this case, when we choose x equals to 0, our denominator is 0. Sorry, when we choose x equals to -6, our denominator is 0, right? So -6 is the number that make denominator equals to 0. So our vertical asymptote is x equals to that number, which is -6. So this is the vertical asymptote. Okay, you might get a 3 vertical asymptote. Okay, so you're gonna find every number that make denominator equals to 0, and once you have those number, make sure you write x equals to that number one by one. Like if you have 3 different number like 1, 2, 3, then x equals to 1, x equals to 2, x equals to 3. Okay, so you have to write each equation for each vertical asymptote. Okay, now what about the horizontal asymptote? How do we find the horizontal asymptote? What do we need to know to find the horizontal asymptote? We need to know the degree of numerator and degree of denominator. So let me write function one more time. So -2/x plus 6. Now for this function, what is the degree of numerator? This is a constant, right? -2 is a constant, and every constant has a degree 0. And what is the degree of denominator? 1. Now here our degree of numerator is less than degree of denominator. So if we have the degree of numerator n less than degree of denominator, then the horizontal asymptote is always y equals to 0. Okay, if the degree of numerator is equals to degree of denominator, then the horizontal asymptote is y equals to coefficient of leading term in the numerator, let me call a, divided by coefficient of leading term in the denominator. Okay, and the last case is that if the degree of numerator is greater than degree of denominator, what is the horizontal asymptote? There is no horizontal asymptote. So you should know three condition. If the degree of numerator less than degree of denominator, this is the horizontal asymptote every time. Okay, if the degree of numerator is equals to degree of denominator, then make sure you write down y equals to, you find the coefficient of leading term in the numerator divided by coefficient of leading term in the denominator. And if the degree of numerator is greater, then there is no horizontal asymptote. Yes.
Is that the same thing as undefined, or we have to put no horizontal?
We do have the asymptote, but not the horizontal asymptote. Like the one, there is a slant asymptote. That's what we skipped in our last lecture class. Okay. Now, when we have the degree when the degree of numerator is greater than degree of denominator by 1, we do find the asymptote, but there is no horizontal asymptote. I mean, asymptote can be vertical, can be horizontal, and can be slant. Okay, the asymptote can be like an incline. That's what we skipped. So for this exam, you are not preparing on that. So if the degree of numerator is greater than degree of denominator, you just write down no horizontal asymptote. Okay. Now for this case, our degree of numerator is less than degree of denominator, so this is the horizontal asymptote. Our horizontal asymptote is y equals to 0. Make sure you are writing y equals to 0, y equals to, okay, this is a horizontal line. The next type of question you're gonna have is here is that, so you are asked to find the domain. Yes, you will be asked to find the x-intercept and y-intercept. Finding x-intercept and y-intercept. The function is f of x equals to -2 over x plus 6. Okay, now how do we find the x-intercept? What do we need to do to find the x-intercept? Every point on the x-intercept has a y-coordinate 0, right? So we substitute 0 for y-coordinate, and in this case our y is f of x. So you substitute 0 for f of x equals to -2 over x plus 6. Now we have this denominator. We need to get rid of denominator at first. And how do we get rid of denominator? We use the same denominator to multiply both sides. So we multiply both sides by x plus 6. So this cancel. So we have 0 times x plus 6. 0 equals to -2. Now is 0 equals to -2? That's false, right? And if this is false, means what can we say about the x-intercept? There is no, yes, it does not have x-intercept. So no x-intercept. Now let's find the y-intercept. And how do we find the y-intercept? What do we know about y-intercept? Yes, so y-intercept has x coordinate 0. So you substitute 0 for every x in this function. So we have f 0 for every x. F of 0 equals to -2 divided by 0 plus 6. So we have -2 divided by 6, that is -1 divided by 3. Okay, so when you are finding the y-intercept, you substitute 0 for every x in the function. Okay, and the last question for this type is you have to draw this rational function. So you have to sketch a graph, rough graph for this function. The last is graph, using the information that we calculated here. Okay, so in order to graph, so we need a x-axis, we need a y-axis. Okay, when you are graphing rational function, we graph the vertical asymptote, horizontal asymptote at first. Okay, so let's go back. Do we have vertical asymptote? our vertical asymptote is at x equals to -6. So at -6, let's say this is -6, we draw a vertical line. Okay, so at -6 we draw a vertical line. This is the vertical asymptote. Next we draw the horizontal asymptote, and our horizontal asymptote is y equals to 0, and y equals to 0 is x-axis. Okay, so we draw horizontal. This is our y equals to 0 horizontal asymptote. Okay, now what is the, it does not have a x-intercept, so the graph does not cross x-axis. We do have the y-intercept. Y-intercept is at -1/3. So let's say this point is -1/3. So graph crosses this point. Okay, okay, now we can make a, now we have to graph. So we have this one vertical asymptote, so we're gonna have a graph in this side, one part of a graph, and we're gonna have a other part of graph on the other side. Okay, so let's make a table. Let me write a function one more time. Our function is -2/x plus 6. So let's make a table. So we have x, we have f of x. So I want you to choose, once you know the vertical asymptote, I want you to choose a number very close to -6 on the left and on the right. Okay, now we are doing for the left side. So what is the number very close to -6 on the left side? Can you just pick a number? Negative? Can we choose? I know it's a close. Can we choose like very close, like -5.9? Oh, is that so 6.1. So -5.9 is on the right side. So we want to know a number very close to -6 on the left side. So it's gonna be a 6.1, right? -6.1. So let's choose that number. So if our x is -6.1, we find the output. So we have -2 divided by -6.1 plus 6. So we have -2 divided by -6.1 plus 6, that is -0.1, and -2 divided by -0.1, that is 20. So we have 20 like somewhere here, right? Now let's choose some number. Yeah, so if you have one very close, that should be enough. Now let's choose 8, -8. So we want any number on the left side. So if x is -8, what happens? -2 divided by -8 plus 6, that is -2 divided by negative, we get 1, right? So we get 1. So we get 1. So when our, so let's say this is -8, we get 1. Now let's choose some very small number, like on the left, like -100. So if x is -100, what is our output? So we have -2 divided by -100 plus 6, -2 divided by -94, and that is close to 0, right? Positive 0. So the 0 point some number. Okay, so when we had, okay, we had a 20 here. I forgot to write down. So we had a 20 here, we had a 1 here. So can you just help me here? Can you just divide a -2 by -94? 0.021. Okay, that should be enough. So let's say this is -100 and somewhere here. Now we connect these points, and it does not have an x-intercept, right? So it does not crosses the x-axis. So it connects all these points. Okay, it goes like this, and it does not crosses the vertical asymptote also. Okay, so it goes like this. Okay, so this is on the left part. So I want you to choose the number very close to vertical asymptote and the very small and somewhere in and one somewhere in the middle, okay? And if you have 3, yeah. Now let's do the same thing on the right side. Now on the right side, let's choose a number very close to -6 on the right side, which is -5.9, right? So we are drawing graph on the right side. So let's choose -5.9. So if x is -5.9, then we have -2 divided by -5.9 plus 6. So we have -2 divided by 0.1. We get -20. So we get -20. So -20 is, so this is -5.9. And -20 is somewhere here, let's say, right? Now, we already know this point here. So let's do somewhere here. So the point is like, let's choose like -2 or negative, okay, -2 or -1. Okay, if x is -2, we have -2 divided by -2 plus 6, -2 divided by 4, that is -0.5, right? So just correct me, okay? So -0.5, so that is -0.5 somewhere here. So okay, now let's choose some number, very big number like 100, positive 100. So if x is positive 100, we have -2 divided by 100 plus 6. So -2 divided by 106, we get like 0, should be -0 point. Can you help me? Can you just divide -2 by 106? 0.0. -2 divided by 106. -0.018. Okay, that is very close to 0, right? So somewhere here, let's say. So you connect all these points and you get a graph, and make sure it does have to cross the y-intercept, okay? So the very close graph looks like this. You don't have to be exact, okay? You can just make correction. So let me make this is -1/2, the y-intercept, and this is the graph. Yes.
And what is there sort of like a shortcut that you pick the exact numbers that you picked before, but from the other side? Like for example, -8 is two units away from the vertical asymptote.
Mhm.
So if you pick 2 units from the right side, which
Right.
is -4,
Mm-hmm.
you get the same thing, which is 1. Like
Oh.
for example, that's why we got from -6.1 and -5.9, we got the same thing.
Oh, okay, yeah, yeah. So if you can choose that, but you are not required. Okay, but whenever you are graphing the rational function, make sure you choose the number very close to the vertical asymptote, and the very big number and a large number. Okay, and I want just like a rough graph. Okay, so you don't need to be very precise, but yeah, you can choose that also. And here we can graph this function using the transformation. Okay, if you know the transformation concept, you can use that transformation concept here. Like if we want to use a transformation concept, what is the basic function for this one? So this is a rational function, right? And the basic function for rational function is 1 over x, right? And the graph of this function is, so this is the graph of this function. Okay, now maybe, okay, should be other side, yeah. So this is the graph of the basic function, this is on the other side. So our graph is this. Oh no, I was supposed to draw this way. So this is the graph for this basic function. Now how can we get this function from this basic function? So if we compare For 1 we have -2. For x we can have x plus 6, right? So how do we get negative? So what does happen when you multiply a function by negative? There occurs a reflection. So you have, okay, the reflection, so you reflect the basic graph. Now I know this, okay, this is again wrong. The reason is that this is our final graph. The basic graph looks like this. Okay, this is the graph for this function. Now we reflect this graph, okay, and x plus 6. How do we get this one? We substitute this x by x plus 6, and when you replace x by x plus 6, we shift our graph on the left by 6 units. And if we shift this graph on the left after reflecting, we're gonna get this graph here. So that's how you can just make check also. Okay, so these are the type of the question that you need to practice for your exam. So one more time. Yes, you have a question?
Yeah, so can we just do that then? Like we see like the original, like
Now here it depends.
we
Now
do, like the actual like the table and all that.
so here, so on your exam, I'm pretty sure that you will be asked to use like these parts, like using the A. Okay, now this is our A, this is our A, this is B, right? So this is our problem C, and yeah, so you are asked to use A, B, C to graph. So you need to use those vertical asymptote and a table. Okay, but if you have this question and you are asked to use the transformation, then you can use. But make sure just you read the instruction very carefully. Okay, so one more time, from section 2.8, you're gonna practice the question and graphing a function using a transformation and writing the transformation. That's the one type. Second type, you will be given a description of a different transformation and you are writing the function on the basis of that transformation. That's the 2 type. From section 3.1, you will be given a quadratic function and writing that quadratic function in a standard form and finding the vertex. That's the next type. You will be given a quadratic function, finding the vertex, finding the axis of symmetry, graphing that quadratic function. The next question, you will have a real life application, that is from section 3.1. So you will be asked to find the maximum value and minimum value, and that is same as finding the vertex. And from section 3.6, you will be given a graph, asked to find vertical asymptote, horizontal asymptote, domain, x-intercept, y-intercept. And the next type is you will be given a function like this, and you will be asked to find the horizontal asymptote, vertical asymptote, graph, x-intercept, y-intercept. Okay, these are the questions that you're gonna have. You can have the exact same thing. The only difference is that you get the different function, you get the different graph. Okay, but if you practice this and if you understand this concept, you should be good. Okay, so let's do this much for today.